Okay, so does anyone remember how we should start a system of three equations always? Solve for one of your variables, sorry. Solve for one of your variables. What are you looking for when you're trying to solve for a variable? A coefficient of 1. And it can be any of the variables, doesn't have to be x, just whatever is easiest. Now in this case, x really is the easiest one. On that top equation, that's probably where I would go, right? So we would start our first step by taking our first equation and solving for x, which is basically just going to be subtracting off the 3y to the other side and the 4z to the other side. Okay, does anyone remember what we do with that? Substitution into? Right, with the remaining equation. So we used this equation right here to solve for x, which means that in the next couple of steps we're going to be using the other two remaining equations and just plugging in our x value for these x's. Okay? So for the first of the two equations, you're going to have 3 times the value x, which we have found our value of x to be 1 minus 3y minus 4z. And then we use the remaining part of the equation from the original, plus 4y plus 5z equals 3. All right. From here, we just want to simplify it down as much as we can. You should end up with an equation of two variables with a constant on the right-hand side. So we'll distribute the 3 into all of our pieces. That's going to give us 3. Whoa. 1 second. All right. Sorry about that. So that's going to give us 3 minus 9y minus 12z. And then we still have the plus 4y plus 5z equals 3. Combine your like terms. So again, that's just going to be taking your y's and combining them, taking your z's and combining them, taking your constant over here and subtracting it off of the constant over here. So that's going to leave us with, taking the y's, we have negative 9y plus 4y is going to be negative 5y. Okay, and then we've got minus 12z plus 5z is minus 7z. If I subtract the 3 to the other side, I'm going to be left with 0 since I had 3 on the right-hand side already. So there's one of my equations in two variables, right? All right, so I still have to do this for the bottom equation. I don't have a coefficient on the x, so I can go ahead and just put in my x value. So 1 minus 3y minus 4z. And then the rest of the equation is plus 8y plus 11z equals 2. All right, there's nothing to distribute in this equation, so I can just start combining my like terms. So my 3's, or my y's, I have negative 3y plus 8y, leaves me with positive 5y. Okay, for my z's, I have negative 4z plus 11z is positive 7z. If I subtract my 1 to the other side off of the 2, I'm left with 1. You just joined my class? Okay, give me 1 second. Oh, you're fine. Okay, so now we have our system of two equations and two variables. Based on that stuff, we've picked up this equation in terms of y and z, and we've picked up this equation in terms of y and z. So now we can solve this just like we've been doing since Algebra 1. All right, so I'm going to take that up to do a step 2. So step 2 is going to be to solve this system. I like to do usually elimination at this point. It's kind of my personal preference, but like I said, if you like doing substitution, you can do substitution at this point. It won't really matter. Oops, I wrote the wrong variable there, didn't I? That should be a negative 5y. All right, and then we've got positive 5y plus 7z equals 1. What do you notice happens here? Right, so I don't even have to do really an elimination step. What's going to happen are these two are going to cancel out. I'm going to get 0 on this side, and what am I going to get on this side? 1. So that you can still get no solution at this point. Okay? Any questions on that? Okay, now had that not dropped out, you would have found a y and a z at this step, right? And then your third step would have been, just to kind of remind you, where's my arrow? There it is. Your third step would have been to take that y and z and plug it into this x equation to find x, and then that would have given you an xyz solution.
Wait, can you repeat that?
Yeah, so in this step, it is possible that you find a y and a z, right? So that you have one variable that solves in this case, plug it in to find the other variable. You end this step with a y and a z. Your last step for the whole set then would be to come up to this equation right here from the beginning of step 1 and plug in that y and z that you find. That will give you an x value. And then you have all 3 variables in the end. And that was the example that we did yesterday. All right, so you should use yesterday's example and then today's example as well to kind of help you through that worksheet. There's a chance that you're going to be getting some no solutions, all solutions, or just one set solutions. Be ready for all of them. I would recommend for that worksheet, you're probably not going to be able to fit all of this work onto that paper, most likely. So I would do your work on notebook paper and just staple it to the back of the worksheet when you're done. All right, so you've got the class period today. I am going to be expecting you guys, and I think what I'll probably do is print off a solution sheet. What I want you guys to do is work starting on number 1. When you get number 1 done, come on over and get it stamped by me so that you know that you're doing it correctly as you go. All right, I'm going to be paying attention to how many you guys have completed. If, let's say, the average, the class completes like 7 of the questions and you've completed 3, I'm going to probably be talking to you and you're going to be losing some points for that. So I do expect you to be working in line with everyone else. Okay, my expectation is that you should be able to get through probably the whole worksheet if you're working well. If not, I would expect that you can at least get through 5 of the problems. So that is your goal, is to at least finish 5, but even if you finish 5, continue on and get the whole worksheet done, okay? All right, so you have the rest of the class hour on that.